Welcome to aminacademy.com. In engineering mechanics, let us discuss about simple harmonic motion. Look at this beautiful picture. A little girl swinging in a park. Here, suppose somebody push her so she goes to and fro like a swinging. This is a very good example for simple harmonic motion. That means at the particular towards the particular position, her acceleration towards its center. That means what? Towards the center is accelerating is increasing, and from the center go out the acceleration is decreasing. Like this it swings. So that means it's a very good example for simple harmonic motion. Look at this. Here a wheel, for example a cycle wheel, is rotating like at the periphery of the wheel. Consider a point P. So if you consider the position of a point and draw in the graph like so, while rotating this wheel, the position of P forms a smooth curve like this, a simple harmonic curve, like it is also a sine curve. In mechanics and physics, simple harmonic motion is a special type of periodic motion where the restoring force on the moving object is directly proportional to the object's displacement magnitude and acts towards the object's equilibrium position. It results in an oscillation which is inhibited by friction or by other dissipation of energy. Continues if there is no friction and dissipation of energy, it continues infinitely. But in practically, it won't continue infinitely because the air friction, and other friction in equipments will slow down and stops the motion. Now look at this. Here this figure. Here the circle, the center O, the point P is, suppose it's here. Let this is theta. Here the position of the point in x direction, like let it be here x dash and x. Here in y direction it is y dash and y. Now we'll explain some important terms regarding simple harmonic motion. First, amplitude. It is the maximum displacement of your body from its mean position. That is from the mean position is here center. This is the from O to x, and O to x dash is the, that is O to x is the amplitude. Here that is, you can define this one as it is the maximum displacement. It is the maximum displacement of your body from its mean position. That is, here amplitude is ox or ox dash, and oy or oy dash is the amplitude. That means it is the radius of the circle also. It is the radius of the circle. look at this figure. Here amplitude is this height in the curve, from the mean position, this is a mean line, from that to the highest point, or from this to the lowest point is the amplitude. Next is oscillation. We'll write clear. It is one complete vibration of the body. It is one complete vibration of the body. Here that means the position and from here to here. That is the, here we can see this one oscillation means the point from O to and come to this position. When a body moves from Y to Y days and then back to Y, that is, suppose a body moves O to Y days and Y days to O and O to Y. That means from, suppose from center to go this, come back and come this extreme, come to the original position center. And next is beat. Beat, it is half of the oscillation. Half of oscillation. That is, the body moves from Y to Y days. That is, suppose body moves from Y to Y days or body moves from X to X days. This is a one beat. Periodic time. Periodic time. It is the time taken by the particle for one complete oscillation. It is time taken by a particle for one complete oscillation. This time period we can write T equal 2 pi by omega. Here T is the time period, omega is angular velocity of the particle, where omega is angular velocity of the particle. Particle in radian per second. The periodic time is independent of SHM. The periodic time is independent of periodic time of SHM simple harmonic motion is independent of time, independent of amplitude. Periodic time. Next is frequency. It is the number of cycles per second. It is number of cycles per second and is equal to 1 over t, 1 over time period, and it is noted hertz. Its unit is hertz, that is we can write Hz. General condition for SHM, simple harmonic motion, which is its acceleration is always directed towards the center. First one is its acceleration is always directed towards its center, which means the swing goes towards the center, its acceleration is increasing, and from center to extreme position, its acceleration is reducing. Second one, its acceleration is proportional to the distance from that point. We have done. Please subscribe our YouTube channel.